My name is Daniel Kim. I'm the founder CEO of Lit Motors. We're a vehicle transportation startup. We're based in San Francisco, and we're in our Portland office now. I'm happy to report we have a brand new team. If anyone knows me, but who I have present is Volker Kase, David Bailey, and Stefan Schaefer. And we're going to go into some quick introductions of who we are and why we're here and what we're looking forward to. So I'll give it to Volker first.
Yeah, a short intro from my side. Hello, nice to meet you. I've been 20 years with the VW Group and set up as innovation management of VW since 2005. One of the highlights of my career was to build the first hybrid car in the VW Group. It's the XL1 with 307 miles per gallon. And after this, I went to my last career step, stayed 8 years with Audi. And there I took care for the transformation from ICE to EV. Spent in this 8 years 1.5 billion to put in new vehicle architectures and technologies for EVs. And last summer I decided I look for some new impact and left Audi, and now I'm with Lit Motors. Happy to be here.
Yeah, thank you. Happy to have you. So.
Okay, I'm David Bailey. I worked in controls. My whole career at Honeywell was model-based control design. I worked for them for 36 years. The last 15 years of that was working on control moment gyro controls for Earth observation satellites. And in that period of time, I was able to solve a stability problem, a singularity in the control moment gyro arrays, and that gave me quite a bit of recognition in that small group. When I was contacted to look at the controls for this vehicle, I realized that there weren't very many people with control moment gyro background that could attack this problem, so I said that I'd work on it. I'm a team member. I'm also an investor in this project. I really believe in it. This second generation of controls is quite a remarkable performance. We're looking forward to building this so that other people can really sit down and experience what it's like to be in a self-balancing two-wheel vehicle. It's going to be an exciting change. And this is Stefan.
Hello, I'm Stefan Schaefer. I'm the Vice President of Chassis and Integration for Lit Motors. I've been over 23 years with Audi. During that time, I was in different departments of the production, the quality. The last years, I was in the technical development. I was responsible for the Audi show cars as a leading project manager. There we built a few really cool cars, like the Audi A-Can, maybe, or Audi A-Me. And one of my last projects was Audi e-tron GT concept. Was really good. I think we make a big event in LA downtown and drive through the city with some journalists. That was really good. And during that time when I was in the quality, not in the quality, in the development, I met Danny the first time and get the chance to evaluate the project, the C1 a little bit. So we talk a little bit, and I get the chance to make some impact with Lit Motors, and I get the chance to shape the future a little bit. And I think over the years, or you get such a chance once in a lifetime, and a car maker, Lit Motors, comes up every one time in a century, I think. So I take this chance, and I'm happy to be part of that team. Really happy.
Yeah, we're incredibly happy to have both you and Volker. I think it's and Dave.
which is I mean, I think the engineering team is very, very interesting. It's a dream come true for me. I'm incredibly grateful just to have everyone here. We also have Mike Bailey on the line as well. Mike, it's can we unmute you and maybe you want to talk about your background a little bit?
Sure. I've spent most of my career at Raytheon Missile Systems. I was once the chief engineer on the Javelin program. I'm currently the lead system engineer on one of the DARPA hypersonic missile programs. I've done a lot of work in embedded controls, embedded software. Like I said, right now I'm a lead system engineer, which means I'm responsible for the performance of whichever program I'm working on at the time for the entire system. I have a extensive background in embedded software and digital electronics controls. Implemented various controls similar to what we need on this system many times. And yeah, again, this is a project. It's rare to get to work on something like this. I think this technology. I really just want to drive this car. I think it's going to feel like flying an airplane 3 feet off the ground. So I'm really looking forward to being able to drive it.
Yeah, thank you so much, Mike. It's awesome. I mean, we have I feel like a pretty amazing team. What are the things that you guys, felt that really drew you to Lit Motors? I'd be interested to hear from all of you what really drew you in and why you decided to join the team.
So from my side, I was tickled by the idea. This is a new car concept, a new class of its own, and it solves a lot of problems. You have like this lane splitting, a tight car, but with all the safety features of a passenger car, but the agility of a motorcycle. Mm-hmm. So this best of both worlds comes together: the safety of a passenger cell and the agility of a two-wheeler. And to engineer this from ground up is one task. But the second topic is we have these gyros in with the controls, and this is a USP. So it's not only an idea. You have something intellectual property in which was investing, was spending time, and from there on, they will take it.
I was first intrigued with the complexity of the math problem that this presented.
Or how did we meet? Actually, that's an interesting story too.
Yeah, there was a professor at Cornell that talked with Dan and recommended me for being able to solve this problem of the model-based control. The first generation of control suffered from not being able to get a real good model together. So when Mason recommended me, Dan and I talked for several hours, and this is an interesting problem because you start with some dynamics in what the controls people would call the right-hand plane, which is an unstable area. I mean, this vehicle, if you take the control off of it, it falls over, so it's unstable. And so we keep it in a stable equilibrium place. And so it becomes a very nice problem to solve. It also was a vehicle that gave a lot of opportunity to crowded environments. And so it's a neat vehicle. There's an opportunity to work on it. It's going to be a fun project. So that all intrigued me.
I mean, I think one of the things that you said in our first conversation is, quote by quote, it's like, "Oh, wow, you found a terrestrial application for control moment gyros." I think that was.
Yes, that was true.
Yeah, and Mason Peck was a friend of Dave's, a coworker of Dave's, and I think at the time Mason had just stepped down as the CTO of NASA, which is where we got the introduction. But it's been a pleasure. I've never met a mind like Dave's in engineering before, and really fascinating, and really just grateful to be working and happy to be working with you. So.
Yes.
Seth, what about you? But maybe go a little bit more background about how we met, and then on the how often we met, and what also drew you to the company as well from your perspective.
I want to start with the other point.
Yeah.
I left my lifetime contract for the project.
Oh.
And that was not an easy decision.
Yes,
but
absolutely.
you are part of that decision.
Yeah.
With the complete team I met. And it was 2018 or
2019.
19 we met the first time. And this was you visit in Ingolstadt. Visit us in Ingolstadt. And
it was a nice flight over. We all had a nice flight over. So
yeah, it was very good. And we speak over the projects I have done. And we speak over the C1. And I think we feel a connection there. We talk really good and really long about the problems we have in the project and how we see the problems. And that was really good. And I feel really good after that talk. That was really nice. And yeah, if you talk to me, hey, Stefan, do you want to join the team here? I thought a lot and speak with my wife. But finally, look at the development for the cars in the last 100 years. Where we come from. And I think this is the next step. And I want to be a part of that step. And with this team, I think we we will deliver a great vehicle.
Yeah, no, absolutely. It's pretty it's amazing. And it was a interesting story how we met. But what about you, Mike? What drew you to the team?
I'm always up for a difficult control problem. I've done a lot of things, a lot of tight controls. Keeping this thing balanced is a totally solvable but challenging problem, and we think we do have a very good solution. All our modeling, all our physics-based modeling, and all our controls theory tells us that it's going to balance just fine. And probably get about 3 times the performance of the first prototype. So, I've led a lot of engineering teams into difficult design phases like this, and this one sounded like an interesting problem to work on for the most part. And again, I really want to drive this thing. I really want to fly down on the ground. So I think that was my biggest draw, is I just thought the vehicle was cool.
It's definitely cool. I think we all are on the same page that this is a cool vehicle, right? But there was, besides the emotional aspect and the huge opportunity for change, what do you all think about, maybe just to get a little realistic, about what are the risks and why is there an opportunity for this vehicle in today, like currently? Like Volker, I think you have a really good 30,000 bird's eye view of this.
Yeah. So just talk first about the opportunities. So with COVID, a lot of people decided to leave public transportation. They went over to a commute on their own again. And there's definitely a need for a small car with a small footprint that people can commute on their own. But in this commuting, you do not want to lose all this comfort. And Bitmotors makes a big step in front. It's not only like having the minimum standard, it's a comfortable ride, it's well equipped, it's a high quality interior. And when you get the twinkle in the eye, it makes fun driving. So it's not only like having a solution, like you have an option there, it can change over. No, it's something like you want to be in. And I believe if you go to work in the morning and people see that you're coming in there with a broad grin and you don't lose the broad grin until lunchtime, then people know, okay, it's fun driving and they want the experience on their own. So the risky part about it, I don't know. I see a lot of options here. So maybe you have to talk to me later that we talk about this. But at the moment, I'm talking about fun driving this.
What about you, Dave?
I look forward to working the rest of the way through this stuff. The biggest challenge that I see in front of us isn't really a risk. It's tuning the control so we get the best feel in the driving experience. That's the thing that's you really can't model. You look at it's going to be putting it in the hardware and getting to do the fine tuning on that. It's more of an opportunity than a risk, because we know from working with other attitude controls, we've got a good idea of what direction we have to go. That's going to be fun part.
Those kind of performance specs, you can't get there without this kind of modeling. So it's aerospace grade mil spec model that we're using to predict the performance of this vehicle.
The team considers the gyrotech to be the key innovation. This is perfect kind of segue into, Dave, before we move on to Stefan. But why is the gyrotech the key innovation?
We have a test track that we run our model car through. And in each of the corners, we put a 2 meter spot of ice. And I don't know if you've ever ridden a bicycle and been going in a corner and hit 2 meters of ice, but when your front wheel has no traction, you tend to crash. Well, this vehicle doesn't. Instead of being lean over, it starts to straighten up because there's no centrifugal force. We need to be vertical in order to keep going. And it goes right through the corner, recovers, and goes on down the road. This safety aspect is really a great deal.
That safety aspect does not get better with 3 wheels. You hit a patch of ice, or you have traction issues with that 3 wheels, it's going to skid, it's going to high side, and this vehicle won't do that, because the control moment gyros will counter those roll forces. And I do think it's going to be a safer vehicle, even though it's 2 wheels. It's going to be because it's dynamically controlling balance, because it's always dynamically controlling balance and not just depending on, sitting on 3 wheels. It's going to be more stable.
Yeah, and I think I agree with all those, and it was really nice to have Dave prove that in our mathematic model or the vehicle model. And maybe we should talk about that in a bit too. But I'd like to get to also Stefan, because you were the head of development for the e-tron GT. I mean, with Volker's group at another company. Yeah. Anyway, can you talk about some of the advantages that our vehicle platform has compared to a 4-wheeled EV? Not just maybe just in general, like parts or complexity.
The complexity of that car, we reduce the maximum. So we have not 10,000 parts to build this vehicle. We have 2,000 or 3,000 parts. That is reduce the complexity, the costs, and make it easier to find a failure or something else for the development, also for the customer service. Then that's a very important point. And yeah, also a 2-wheeler, as Dave said, it's a new drive experience.
So from the holistic level is like 75-80% of the drives are single drives. And if you have a vehicle which has safety of a passenger cell and the footprint of a motorcycle, you would use a lot of material and energy and cradle to grave. So you have to build in less material, means like you have to produce less material. But then comes you're not only using less energy to drive it, it's a battery, which is a real big obstacle today for like emission sustainability, producing these high boundings of lithium, cobalt, nickel in there. It's a lot of not rare earth, rare metals, which get high pricings.
Right.
You need less for this. And you come to the same ride experience and the same safety standards. So to achieve the ride experience with 1/4 of the material you have to put in makes it a fully different impact in the meaning of SDGs and ESGs.
Which are incredibly important goals, I think, moving forward to meet those sustainability or like eco goals for the UN is something that the entire Western and the Eastern world are interested in. Maintaining the same value proposition of safety and basic controls and convenience. But I think we can still do it with some extra fun.
Yeah.
Something that we can all enjoy. I think you said keep a smile on your face until lunchtime.
Yeah. So the baseline is achieve more with much less.
Yes.
Yeah. So and at lunchtime you already start grinning again because you know you have to go home some hours later. So it's a short moment.
You can always go out to lunch too.
For the future.
Absolutely. Yeah, absolutely. So what are some of the plans, at least for going into production from now? I mean, I think we have this amazing team. And we've reduced some of the risk. I think maybe Dave could chat about a little bit about the risk that we've reduced. After Dave talks about that, what's the plan for production? I mean, I feel like you guys know this more. I mean, I can build off-road trucks, but you guys have experience with building cars at a very high level in serial production. So maybe we should start with Stefan and Volker.
Plan for that.
Oh, we have a plan.
We have.
That's
absolutely.
That's good.
The road to the prototype. That we build up. So the recap for the customer, we want to make a B2B or then a B2C at the end. And so now we build up the concept. So we start with what the needs from the customer. We want to create a great customer experience. Then we need input from some requirements we have. So the government requirements, the technical requirements, or we build up the technical requirements, better to say. And then we build from that. We start in the construction finally. That's the next step. I think next year, in the beginning of the next year, we can start with the construction. So the next 2 months, we build up the concept completely. We build up finally the technical requirements, and then we go in the hard stuff.
So what Stefan at the moment is doing, like integrate what Dave is doing with the gyros.
Yeah.
So Stefan is doing the integrate the bodywork, how to engineer it, and make their proper concept. And in parallel, we have to look at already all these classic obstacles for ADV startup, to hire the right guys, to find the right guys, to have access to batteries. We have a good network there right now, but as well have access now to someone who's delivering the ICs later. Some ICs you have to order a year before you go to production. So what we are doing is simultaneous engineering, doing the controls work, doing the vehicle work, and in parallel with this prototype, we are already looking in simultaneous like what we need for serial engineering later. You cannot start some task when you need it. You have to start one by one.
Right.
Same as like when we have the prototype, we already look in what is later the production concept, what is the production lineup, where we want to produce it, means like which technologies we have available. It's a lot of handwork or a lot of robots working on this, and this influences the lineup, how we bring parts together. This must be now already in Stefan's head. We cannot make a prototype now, like, and say it's driving. No, it only reflects how we produce it later. And it's like building the prototype now. It's always like thinking about the serial product, and as Stefan said, who's the customer, and we are going first with B2C.
Yeah. And I want to add something. We not just build a prototype, we build a pre-serial prototype. That's a different.
Wait, what kind of prototype?
A pre-serial prototype.
What does that mean?
That means that we are one step before a serial production.
That's like what level of units per year that we can produce? Like, what's the range?
I think the plan is about 100,000 per year.
Wait, sorry. I'm the CEO. I'm just hearing this.
I'm wrong.
100,000 units. That's what the work that we're going to be doing over the next year and a half.
That's a
Maybe.
target that is possible. Yes.
Yeah, and the number is feasible from the side. You can go with contract manufacturing in numbers between 5,000 to 30,000. This is the maximum we can get in US from contract manufacturers for a vehicle. But if you're going over this number, you have to build your own plant. So we call it a slice. The slice is 100,000 cars per year. Means you have 2 or 3 shift operations there. And if you run into this game, then you really use your investments and produce cars. You can get 40, 50,000 cars out of the same investment. But if you're bringing out 100,000 cars, you have the same investment, double of the revenue. So this is why Stefan is saying we use our experience from the VW world, 100,000 cars as well as looking at. We have a lot of technology in this and have to bring this in that you come to a target of 10 engineering hours per vehicle. Yeah, but to scale up, we just take the same line as we say 100 to 1,000 is one car line. Then you can reproduce it and set up another 100,000 line. Yeah, so like that. It's used to the companies we are coming from. We just set up another plant next to the other plant and use the same supplier park, which is in between the 2 lines.
Yeah,
it's easy to reproduce, but don't press 400,000 cars through a line which is built for 100,000.
Yeah, but we think.
I think the
also not just the car production, also the storage for the parts when you deliver it to the lines or something else. If you have lesser parts, you have lesser costs, for the production, and that is also very important.
Yeah,
that we have that in our mind.
Yeah, the only thing I was going to
Mike.
throw in there as well was, just the complexity and the upfront cost for tooling up a factory is going to be substantially lower for a vehicle like this, just purely because of the lower parts count.
right. And this
you
is
know,
Go
when
ahead.
we get to that point, where we're trying to capitalize for production, this is not going to need to be such a substantial investment as it would be for a 4-wheel vehicle.
right. And no one's ever built a vehicle like this ever, correct? I mean, okay, good.
It's unique.
It's a clean sheet development cycle that we're just about to enter, right? No one's ever built this before. How much capital costs or the requirements, at least at company A or V, how much of that costs to develop from a clean sheet?
So the basic number is like, and Stefan, please correct me, if we are going for this first fully functional prototype, it's a number between 3 or 5 million US. Then you go in the next step, the serial concept development. It's a number between 4 and 8 million, just to know what you're doing. And then you go to the next step, do a 2 years maximum serial development. It's a number between 60 and 150 million.
Okay.
And then you make the classic cut down and say the money you spend on engineering a vehicle already reflects the complexity of the parts you're buying, how many parts you're buying, and then you just triple or 5 times the number of engineering costs. So if you have a simple vehicle, then you go later in the production, maybe from 60, you need investments of 300 million to set up a plant. If you have a very complex vehicle, like 250 million, then you have to invest $1 billion or more in a plant. So what we are trying to achieve here is we stay on the flight level of a vehicle, of a simple vehicle with a reduced number of parts, and keep the ballpark of engineering below 100 million. So from there on, you can easily go to say later we need another 400, 500 million for to set up a proper own plant.
Right.
But what we do first is go to contract manufacturing, learn about it, get customer feedback. And with this customer feedback, we can hone our own product and production engineering. And then we set up our plant properly. To run first in an own plant is like we learn with the money investors give us. And I would like to do the first production with someone who has experience there, mirror this experience with a special type of car, and then roll out the own plant.
Okay.
It's better. It's better. And spend the money carefully and with a lot of experience.
It's our job. It's our job. It is your job. Thank you. I appreciate it. What about you, Stefan? Do you have anything to add to that?
No, I think Volker explained it completely. So I'm with him, and yeah, we have to make the money is an important step for the next years, that we are very carefully with that. And also in the development, we have to keep in our mind what is our target in the end. And the complete team, I think, is in that mind, with that mind, you know. And that is an important step. We have all in the team the same target in head. And that is, I think the achievement is possible for us. Absolutely.
They said it. So yeah, that's excellent.
Yeah, absolutely.
Mike, do you have anything to add?
No, I think we are in good understanding of what it's going to take to get this done. I think we can do the lean and mean to get that first prototype out. And I'm in agreement with Stefan, who's also in agreement with Volker. Therefore, I'm in agreement with Volker as well. But yeah, we're all good. We understand that the task at hand.
Yeah, and you know, before we open up to you know, our audience, you know, a lot of this is I mean, I think the plan is there, and we just have to execute it, you know, with some financing and you know, staffing up. But you know, I think we have the core executive engineering and development team, but this is all backed with, it has to be with some kind of hard asset, right? And I think that, you know, being the CTO and Dave's kind of actually acting as a you know, co-CTO. Dave, do you want to talk about your background and patents and maybe how many you have, and how many you've contributed to the team?
You know, over the years, I've accumulated. At this point, it's 23 patents. I've got 4 pending. 2 of those patents are lit patents. All the pending ones are all the. I would say probably over a third of my patents are related to some kind of singularity and how to solve a singularity problem. And, of course, in this one, our singularity problem is the fact that the vehicle falls over if we don't do anything.
Yeah,
That's a good sentence.
yeah, it's the biggest understatement of the year. So yeah, I mean, you know, it's been a pleasure to work with Dave on the last 7 patents that we filed, and 2 really paramount patents that have reset our patent clock till 2037 or something like that. Yeah, it's for a while. And you know, that's really kind of the base foundation for the company. Is we're very heavily control patent based and are definitely utility patent based. And, I think that's just really a nice kind of safe net for us all. And, when we were chatting with you guys over the pandemic, that was a really interesting back and forth, monthly or bi-monthly. And we're really happy to have you guys here. So host.
Pleasure for us.
So we should open up to some questions to the audience. There's some 4 people here who
I have a question.
Jim.
I can go first if you want.
or Erickson. Yeah, go ahead, please. Yeah, Ed, yeah.